The next unit is all about multiple access methods, uh, which is one of the main responsibility or the function which is to be carried out in your data link layer. Just a second. Okay. Uh, so multiple access method. We were already discussed about this. Why we need a multiple access method. So before that, we just talked about the type of links, right? So there were two types of links. There were two types of links. One is a broadcast link, and another one is point-to-point link, right? So the another one is point-to-point link. So there were two types of links were there. One is broadcast link, and another one is point-to-point link. So what it exactly means, point-to-point link, a device would connect it to another device with a dedicated link. So it's what you mean by call it as point-to-point link. Okay, this is P2P link, where two hosts were dedicatedly connected. And in this type of links, probably we may not need of um, multiple access method, because this link is mainly meant for them to communicate. Okay, so in this type of links, if you connect them, then probably we may not be required of. Just a second. If anybody who joined late, I just disconnect them to get joined to this session. When I sent a link, just discuss. I sent on 10:30, and still now it is 11:10. Still people are joining. Ask them to join 5 minutes early. Okay, Anubhav,
Yes, sir.
you just inform them to join 10 minutes before the session when the session will start.
Okay,
Okay.
sir.
In even also send a link earlier, so that we should not waste time after the times which I start when I start.
Okay, sir.
Okay. Okay. See, when I switch to the slides, see, I'm getting many requests to allow the students who are joining. That is the problem. I can't go there and again come back and allow them something like that. Okay. So in this type of link where we may not be need of multiple access method, but when we need a multiple access method is whenever we use a broadcast type of connection. So what do you mean by broadcast type of connection? So where there will be one link, to that link there will be multiple hosts were connected. Okay, could be a bus topology kind of thing, or it could be any other way, where a common channel would be shared with a multiple users. So then there is a need of multiple access method. So due to this multiple participant to a common channel, so there will be an access method who control all these hosts. So in order to communicate over this same channel successfully, means what? If they would not having any access method, probably there might be confusion, not confusion, I would say. There might be a chance of collision. Okay, what might be the chance of collision? At the same time, there might be more one station can access a channel and they can send its data to someone. Okay. In situation, it might be not what is actually, there will be a road. The analogous is like this. So there will be a road where if that is this road is two-way, probably you can allow them both the sides. One traffic they can go in this way and another traffic they can come in this way. So there will be no collision, right? Even though if they are going in the both directions simultaneously, there will be no collision. So what if this would be a single road? Okay. Or what if that road which is made up of one way traffic only allows the one-way traffic, and the traffic should only flow in the only one direction. If someone would come from this direction, what will happen? There will be a collision, right? So here also the vehicles will come. Here also one vehicle comes. At somewhere at some point there will be a collision. Okay. So in a broadcast link, since this channel is been shared with the multiple users, okay, so this you can think of the users would be represented with a road. Okay, this is one highway road where the users who are connected to this link, probably you can think of an adjacent road or a road which is joining to this main road. Okay, so due to looking at this scenario where you should put some strategy and access method to allow only traffic from each one of this road to a main road, okay, at some interval of time, or it could be some other methods where there will be no accident would be occur, isn't it? If there is, you don't have any access method, probably some vehicles would also come this side and also they would come this side as well, from this side as well, from this side as well. If all vehicles are allowed at any time, at any point, like without any access method, probably there might be chance of collision between the vehicles. Okay. So what we were doing here, we were putting up some strategies and how we can avoid the collision and make an host who gain an access to the channel for their successful communication. Okay, that is what we would call it as access method or multiple access protocol. So we would also call this as MAC protocols. So what is mean by MAC protocol? Media access control. Who will have and control over on a media for the accessing. So that is what we would means to say MAC control protocol, MAC protocols. MAC protocols, media access control protocol. Who will have and control on the media for the accessing, or when and where they can access the media, okay, and have a control that medium, they would, so that is we would mainly call it as the procedure which everyone follows, okay, to access this media and having a control on it is what we call is a media access method or MAC protocols. Okay, okay. So in the last class we just talked about. So I think we already know that initially we made an assumption that, so we were looking at DLL into two sublayers. One is data link control or logical link control, DLC or LLC. And another sublayer, we have something called media access layer, sublayer, MAC layer, or multiple access resolution. So this yellow color, what we represented in this box, is actually we were discussing in this unit. Okay. So the half of the unit we were talking about all these protocols. Then later we will try to understand the standard which is made, okay, by an IEEE for an wired LAN. Okay, all this wired LAN with respect to the physical layer and the data link layer. Okay, we were looking at in the next half of this unit. Okay. Okay. So we were now looking at exactly at this layer, which is MAC sublayer. In specific, we were mainly discussing about media access control protocol. Okay. So after we understanding why we need of multiple access method, so we were able to categorize them due to having various strategies where you can put in to avoid the collision. Okay, in a network. Okay, since you have a broadcast link, what are all the strategies or a protocol that you would able to develop Okay, in order to have an efficient and more efficiency for accessing for an each host which is connected in a common channel, and having a fairness among them. Okay, because if you would have a channel where there are 100 nodes were connected, they should be fairly giving an access to each one of them for their transmission. Okay, looking that we were able to categorize them into various uh, categories. Used in computer network, where some of them might also used in different applications of networks. Okay, because Aloha, what we will discuss, yes, okay, yes, yes, okay. Now, hello, it's now audible. Is anyone okay? So whatever we see here, a set of protocols, you should not think that all of them are used in computer networks. Might be some of them are used in different network applications. Network applications, I would say, include radio broadcasting or wireless communication. Different methods, like see, in your cellular network, we mainly use the channelization protocols like TDM, FDM, and GDM. So all put together, we were able to categorize all these multiple protocols into these three major categories. Okay, one is random access protocol, controlled access protocol, and another one is channelization. Okay, so I would like to say that probably these first two we would have we have random access and the controlled access, which were mainly used in our computer networks, and where the channelization might also use, but predominantly we majorly used in our cellular or in mobile communications. Okay, uh, okay, we would use mainly used in mobile communication. Why would grouping some set of protocols and we call them into belongs to one case? How we were able to categorize them based on the nature of how that protocol is designed. Okay, or when and where that protocol gives an access for an host to transfer their data. Okay, is there even control on the access to any one of the host, or they might send by their own? Okay, so based on this, how these protocols were designed and the nature of that protocols gives them an access to each host in a common channel. Based on that, we were able to categorize them categorize them into different categories. One is random access, controlled access, and the channelization. Okay, so in random access, we were mainly discussing here four protocols. One is ALOHA, CSMA, CSMA bar CD, and CSMA bar CA. CD, CSMA is something carrier sense multiple access. Okay, CSMA bar CD is carrier sense multiple access collision detection, and CSMA bar CA is carrier sense multiple access collision avoidance. Okay, all these four protocols are belongs to this category, which is random access. When another one is controlled access. Controlled access is something reservation, pooling, and token passing. These three set of protocols belongs to this category. Where others, what we would have here, TDMA, CDMA, and FDMA, all of them are belongs to channelization. Okay, probably this you would going to study in your mobile communication, but I would also explain, not in brief, I'll just explain an overview on this. So how that would be used and what is CDMA and how that you could use in your computer network and all. But majorly you will discuss this in your mobile communication. So, okay, in mobile communication, in depth you will discuss. You'll understand what is FTDMA, what is FDMA, and CDMA. Probably you might also already discussed in digital or something somewhere in communication. I'll not get into this into detail. Just I'll speak about just an overview about each of this multiple access method. But in specific, I'll just go in detail about each one of them. Okay. So from where that is started and how the protocols works, and we would also try to evaluate them with some expressions of by putting up some mathematics and try to derive an efficiency of this each of this protocol. Okay. I majorly I'll refer this from one of the website of Geeks for Geeks. I think so many of them heard about this website, Geeks for Geeks. I just refer everything from there to derive an expression for each one of this protocol. You just also go and visit and you try to copy down whatever that expression they've written. I will also show you here. If you have any doubts that you can't able to get that derivations or something, whatever I do, you can able to get it from this website. If you're not able to found, you can ping me at any time. Okay. So first one we will look at from under this category, what we would have a random access protocol, ALOHA, CSMA, CSMA per CA, and CSMA per CB. First, we will inspect each one of this, and we'll try to understand in detail about each of this multiple access method. Okay. So before that, we should try to understand why this set of four protocols what we have under this lead, why we were call them. Okay. So here, if you look at after understanding each of these protocols, so by looking at its behavior, whenever any station would have data, and if they have data, then should ask based on this whatever they have use a multiple access method, how they would able to access the channel. Okay. The nature of that this four protocols what you have. Time this randomness
So the
will
voice is
make
breaking, sir.
most of the problem. Still breaking.
Yes, sir.
Is why my voice clear now? Hello, I'm audible now. Am I audible? Is my voice is clear? Is my voice is clear? Okay. My presentation visible? Is my screen is visible? Okay. Okay. Thank you. Uh, I'm just talking about this. Why we call this as random access? So if any station needs to send their data, it need not to ask anyone else permissions. Instead, it can itself wish to send their data. Okay. So means what? If any during any of this collision, most of the time this randomness makes to solve most of the problem. Okay. I mean to say if I ask someone if something in a broadcast environment, probably there is a chance where two of them can answer simultaneously. Okay. If I avoid that time, the situation what that arise, and if I give some times and randomly you stand up and if you say answer, probably most of the time that may solve that issues of collision, right? Uh, so, uh, so the way we call this random access here. Uh, so the host have a privilege to send their data on their wishes. Okay, when the whole each host have their data to send as the data to send. Okay, so that's why we call this category or the set of protocols under the roof of random access method. Okay, the another name to this method is contention method. Due to this randomness, okay, due to this randomness, I said each host have a permission to send their data if it has data to send. Due to this random access, there will be more of collision. Okay, you would get there will be lot of collision. So, so that's why we call this protocol category also as contention method. Contention is something due to this random access to each host, there will be more collision of data because what if you have more number of participants uh, due to this random access, probably uh, any of the host can access the channels at the same time and send the data on the same time. If they would send at the same time, probably if more than one station's data is in the same channel at the same time, probably there might be a collision. Okay, so we would call this as random access and contention method. I think you understood. No station is superior than other station, and none is assigned the control over the another. So that's why we call this as random access. Where the another what we have here, controlled access protocols. So here one node is superior to the next what you call successor. If any of the successor it needs to send a data, it need to ask the predecessor before it's going to send its data. Means what? There will be an access method where if any of the host if they wants to send its data, it needs to take in permission from either a successor or from a predecessor. Okay, if I should say one present station we have, okay, let us say this would be a station where if all of them are connected to a common channel, okay, broadcast link. If this station called B, if they have data to send to someone in this network, either the station should get an access like permission from either a predecessor or it should get the permission from the successor. So that is what we have. Nothing but if this wants to send, it should ask the permission or the control from the other station whether they could send or not. So that is what we call controlled access protocol. Okay. So we will look at that later. First, we will look at what is called random access here. No station permits and it does not permit any other station to send each instances a station. Just a second. Really good, sir. Yeah, yes, sir. A very good morning. Okay. Okay. Uh, at each instance, a station that has data to send use the procedure defined by a protocol to make a decision on whether or not to send. Okay. Uh, so it means what? Based on this procedure or what we define as a protocol, it will decide whether it to send or not. It only it takes a decision whether it's to send or not, but it will always it can access the channel, but they will decide whether at that time it should send or not. Okay, that's why we call this as random access. Under this, so we have four set of protocols. Aloha, carrier sends multiple access, CSMA, CSMA bar CD, and CSMA bar CA. Okay, so this was used earlier days in our radio broadcasting or something in that type of application. Aloha is well used in that Aloha protocol, and CSMA is just a concept to understand what is called CSMA bar C and CSMA bar CA. Okay, where CSMA bar C is used in wired LAN. Okay, wired LAN, where in CSMA bar CA is used in wireless. Okay, so we use this protocol in wireless as a multiple access method in Wi-Fi mainly, and this is the one which is used in wired LAN. Okay, in our LAN network. Okay, so we will now look at what is called Aloha protocol. Okay, so in Aloha, so there were two types. There is an older version of Aloha, and there is another modified version of Aloha. We call them as slotted Aloha. So in Aloha, we have two versions of Aloha protocol. So Aloha in terms is defined into two types. One is pure, I would say, the older version, and the modified version we call them as slotted. Okay, it's very simple. I explained them with the flow chart and this timeline diagram, so that you could understand in a very easier way. Okay. Um, okay. So let us assume all this whatever we written this horizontal lines, all of them are a common channel. You should assume them all of this as a channel. Okay, a common channel connected to four different stations. Okay, station 1, station 2, station 3, station 4. Either they connected either in the form of wired or it might be a wireless, connected in the wireless. Okay, because wireless is also the same thing, right? To a one common central hub where a multiple users were connected. Okay, and all of them are use the same frequency, 2.4 gigahertz. Okay, 2.4 gigahertz. Okay, so just think of where we have a common channel. Okay, where a four stations were connected, and this frames is what is actually each station may have the data as a data, and they will send irrespective of this time by accessing the channel. So I would say this would be random access where each of the station would they would likely to send two frames. Okay, I just name them each frames with whatever the station number that I have, 1.1 and 1.2, and this is 2.1 and 2.2, 3.1 and 3.2, and there is something called 4.1 and 4.2. Okay, so each station has exactly two frames to send. Okay, and I don't know when they were gonna send this data. So that's why, because we said a random access, a station can hold this channel and it can send at any time. Okay, probably you think of at this time where a frame 1.1 are sent, and there is another, like before that, probably point one, like 1 2 is been already been sent. I just taking in reverse the way. Okay. Okay, and the station 2 might send 2.1 here and 2.2. I think the two frames were like lies in this time, where 3.1 would license in this time, where 4.1 and 4.2 would license in this way, in this time, in this time axis, because all of them was common channel. We are assuming these channels in this time, in the time axis. Okay, I write in time axis and assuming the channel be a time, and we were looking at when where a station, all these four stations sent their data. Okay, and we were assuming another one is each station is likely to send only two frames at this given time. At this time, we were assuming each station has two frames to send, and I don't know when they were going to send. Okay, among these four, we were assuming each station has two to send. How many frames that totally all this four and eight, right? 1 2 3 4 5 6 7 8. Totally 8 frames that will send. If you see this diagram, so there will be a collision. Means if any of the frame, the time get overlapped with any other is what called collision. And we would also, you can see the highlighted this vertical box, shaded one. What you would see is something is overlapped, because since maybe all would be the same. Frame 2 overlapping on frame 2.1, this would be on 3.1 and 4.1. Okay, means all this set of frames what we send is already not reproducible. Instead, in this channel itself, all of them might collide and all of this data will be corrupted. Okay, and there is another time in another instance, there will be collision among 2.2 and 4.2, because probably at this time, okay, at this time, both the station 2 and 4 access the channel and they send their data. Okay, but among this total 8 frames, what been sent by 4 stations, each of the station would send to only 2 frames were successfully sent their frames to a receiver. I don't know which is the receiver. That the frames which are successfully sent was 1.1 and 3.2, because at this time none of the station would send their data. So means what? At that time the channel will be idle. Okay, it's free, so that whatever the frames that put by anyone who put in that frame into a channel can successfully reach the receiver. Okay, so we would comes to know all these frames were like damaged or collide during this time. So what happens? So what is the next step? So we should ask them station, each of the station, whichever the frames are involved in collision, to retransmit, right? Either it might be a collision or it might be a corrupted data, because collision is nothing but the data will be corrupted. So if the data is be corrupted, then we should ask the sender to retransmit, isn't it? But the only the possibility is we should wait for some time. We know that the ruling and all, right, the flow control. So if doesn't receive an acknowledgement, and it will, like once the timer is completes, again that will be retransmitted. So because due to this collision, okay, so what will happen? It will wait for some time, and again this would also wait for some time, and this would also wait for some time, and this would also wait for some time. And we are assuming another thing is the timer which is used for each of this frame might be same. Okay, the time at which 1.1, 1.2, 2.1, 3.1, and 4.1 was sent. So probably all the frames might expire the timer at the sender side at the same time. So what will happen? The retransmission would also be at the same time among all these 4, because it has to resend, because it comes to know its own data is involved in collision. Okay, let's take an example like I'll just only take like two station. One is A and B. Okay, let us say A and B. Okay, at exactly time at 10 o'clock or something at 10 o'clock, this data, the station A would also send its data, and this propagation delay from here to here is 1 hour. Let us think of 1 hour. At time exactly at 10, both the station A and B send their data. Okay, send their data. What exactly it happens at 10:30? Can anyone tell what happens at 10:30? So the data which is sent by station A will reach half of the way on its link, and whatever the station B would send, it's also data is along with the channel, and it would also reach half of its length. Okay. At exactly 10:30, there will be a collision among these two data. Right? This data what been sent by A and the data what been sent by B. Okay, and this would collide. Okay, and again this collide signal will be come back on the both the directions, since that would be a broadcast channel, so that will be broadcast to everyone. Only this station A and B would able to hear that there will be collision in the channel. And it doesn't know whether its own data is collide or it's some other data might collide, isn't it? I just taken for an example is only two. Probably it might be connected with so many other stations, C, D. Might there might be chance that C and D were communicated, and its own data, like C and D's data, were involved in collision, and that would might also comes B as well, but also comes to A as well. How a station A and B were comes to know its own data is involved in collision? So we will look at that later. But the point what I'm explaining here, as the stations were comes to know there is a collision in the channel. So what is the solution is? Solution is to retransmit the data. So here in this example, both A and B were transmitting the data and involved in collision. And again, C and D might also send their data and involved in collision. So what happens? So all the station, four stations would comes to know that probably what we were sending, so that involved in collision, so that I have to retransmit my own frame what I earlierly sent. So all the station will wait for some time. Again, they will retransmit the same data. If they retransmit all of them at the same time, what will happen again? Again, that will involve into collision, isn't it? Because all of them are knowingly or unknowingly they send their data and randomly, and that makes to happens a collision. So after all stations would knows that there is a collision in the net channel, again all of them will retransmit the frames at the same time. Again that leads to collision. Again it will next retransmit the frame. Again that leads to collision. How many times that you keep doing the retransmission? Every time that will be leads to a collision. Okay. What this ALOHA would suggest, this ALOHA protocol, instead of all the station to retransmit the frame which is involved in collision at the same time, I just all the stations to select a random time for the waiting period. Means all the four stations should not instantly send. Instead, each station should randomly wait for some time, and after the completion of that time, they should send the data. The only a simple things that what we've added here is during the retransmission, each station should not instantly send. Instead, they should wait for a random time. Like let us say, if the station waiting for 10 seconds and the station 2 should wait for 20, like to be wait for 20, it could be something 40 and it could be something 100. Having this random waiting time across all the stations, probably you might be reducing the collision if you do the retransmission, right? So if we don't know when they were sent, randomly they can send. Due to that, there might be a collision. So if we do retransmission, that leads to have the same picture, so the same collision. To avoid that, so what your pure ALOHA says that protocol, you should not send immediately. Instead, you should wait for some time, so that due to that random waiting period across all the stations who were connected to this broadcast link, so there might be a chance of collision will be reduced. Okay, 10, 20, 40, 100. So again, because if your packet would be more than 10 seconds, like more than a larger length, probably during this transmission still, if this would start, okay, then there again be collision. Understand my point? Okay. That is the one thing we just added. After you following a random time, waiting time across all the station, if that still, if you would able, like if you would able to see something still a collision, so what is the next suggestion by this protocol, what you call pure ALOHA is, you leave that event. So whatever you've been trying, waiting something random time and you sending, even that leads to having a collision, getting in collision. You leave that some time and you try it that in some other time. Means what is the thing here? You keep on trying to your friend to doing phone call, and if you keep on trying every time, if you would get a busy, what you will do? Will you continue the same thing on continuously? No, you will wait for some time, random time like 30 minutes, 40 minutes, then you will again call. Probably that time you may get connected. So when they were talking, if you keep calling them, so what you will get? It's busy only, unless until they cut the call, isn't it? So what is the thing you should do here? The other suggestion by this protocol is you leave that event. You leave trying to retransmitting the same frame at that random time. Instead, you later after some time, after 30 minutes or 1 hour, you again try. Probably that time you may get succeeded to transfer your data. Okay, so what I just explained them, I just represent them in the flowchart. Okay, I start. Okay, I'm just using a variable called k. Okay, where k is tells the number of attempts, or I would say number of retransmission attempts at the LTV, ಅಥವಾ I would call them as retransmission. Okay, how many times that you retransmitted the frame which is involved in collide, or the frame is collide. How many times that you will retransmitted, and still if you are not after some amount of attempts you made, still you there will be collision. You leave it, abort the session, and you try it the same at some after some other time. Okay, that's why we use this variable called k. That is what is called number of attempts or number of retransmission. You send a frame randomly. There will be no condition at all here. There will be no condition statement. You simply send a frame without checking anything. You send a frame and you wait timeout, which is 2 TP. So why it is 2 TP? So I'll just give an example that what you mean by 2 TP. Okay. So before you to understand what is the waiting time, I just first I should understand what is called vulnerable time of this pure ALOHA. What you mean by vulnerable time? It means of the time at which the frame is get involved in collision is what we call vulnerable time. Okay, what do you mean by vulnerability in your system? If anyone asks, like, what is a vulnerability? You'll find what is a loophole where someone they can access, they can get in and whatever they want, they can do it. Here, the time at which when a frame can involve in collision is what we call vulnerable time. Okay, how we'll find for that to pure ALOHA? So let us assume this would be one frame. Okay, this would be one frame. And what is the maximum, like if this is a T, the time taken to put all this data into a channel is what? TT. Okay, here they would taken as TFR. TT ಅಂತ ತಗೊಳ್ಳಿ, transmission time ಅಂತ ತಗೊಳ್ಳಿ, transmission time of frame ಅಂತ ತಗೊಳ್ಳಿ. This is T, then plus 1 TFR is becomes the time at which the complete frames into a channel. Okay, so there might be a chance any other station, or like this is what the frame is transmitted by a station A. Before the transmission of this begins of this data from a station A, there might be a chance where a station B might already sent, means T minus TFR. During this time, probably the some station might already send the data, or after this been transmitted, okay, there might be a chance some other station may start like this station C may start begin the data to send. Due to this, both of this events, there might be a chance of collision. Okay, so the vulnerability time for this is 2FR. Why you call as 2FR? If you have a time period of 2FR, okay, if I say this would be T and this would be minus TFR, okay, and this would be T plus TFR, 2TFR. During this time, if only one station would send its data, then there will be no collision. Okay, during the time period of 2TT, if one station send one data, one packet, then there will be no collision. Understood what is the vulnerability time? The time in which it get involved in collision, okay, is what 2TFR or what you can assume. Due to this vulnerability time, if that during that time, if only one station they would send the data, then you will be able to successfully transmit the data to another. Okay, so that is what they have written here. I'll just explain this diagram. Send and wait for a timeout to be 2 TP. Why this is 2 TP here? I'll just explain you. One is this, and two stations were there, A and B, station A and B, and the propagation delay would be 1 hour. Okay, I just said at 10 o'clock where station A would send and station B would also send at both at 10 o'clock. At 10:30, what will happen? There might be a collision at half of its way. Okay, at 11 o'clock, where both the station would receive the collide signal, isn't it? Since that would be a broadcast, whatever the collide signal is now traveling in the channel or in the link, that will be heard by both of them, isn't it? At 11 o'clock, because at the half of the way, again that signal travels back at the both the side, it would take another half an hour, isn't it? So exactly at 11 o'clock, both will be see the collide signal. So they would comes to know our own data is involved in collision. Okay. Again, they will retransmit. Okay. And why we were waiting time period is 2 TP. So I said if at 10:30 it would happens like this. What if in the worst case I have two stations, station A and station B. Okay. So instead of both will start at 10 o'clock, I'll just say station A would start at 10 o'clock. Okay, they would start the data to send at 10 o'clock. Okay, at exactly at 10:59. Okay, and the propagation delay would be 1 hour. So exactly in a worst case, if B station would start its data at 10:59, there will be a collision at where? At the B side, almost nearer to B side. But the B will be get the collide signal soon. But what is the time taken by a station A to receive the collide signal? It's one more 1 hour. It's nearly 1 hour, right? Or 59 minutes. Because again that signals to come back and reach the station A. So that's why each station should waiting the period of 2 TP, twice the propagation delay. Means one propagation delay to travel its own data from one end to another end where that involved collision, and there might be like a same time taken by that signal to travel back to the collide signal back to the station A. That's why it should wait for a time called 2 TP. Okay, so then it will check the condition whether they would receive an acknowledgement or not. If that get would an acknowledgement, then it will be successful. Otherwise, you increment an the attempt of retransmission let's say the frame which is involved in collision, which is k is equal to k plus 1. Initially it is 0, and I'll just increment that 1. And how many times I'll check this condition? If that reach 15 times, and said that if you keep repeating the retransmission even after the 15 times, if that still equaloid, you leave that event and you do it in some other time. So up to the time I should check, I should keep repeatedly sending. Okay, and I'll check what is the maximum. Normally it should be a maximum of 15 times. So if that is greater, then I will abort and I will do it later. If not, then it will go and choose a random, a number called R, and that is between 0 to 2 to the power of k minus 1. Between this, I choose a random number, and that random number will be multiplied with the back of time. Back of time is the TB is what you call back of time, or I would say it's a random time. It's a random time. It is independent to each host, and it can select based on its back of algorithm. Okay, so it has to wait. After this time completes, again it will comes here and again it will retransmit. Again wait for assignment received, yes, successful, otherwise increment, go it, choose another number and you send it. Okay, this is what the procedure of your ALOHA. Okay, let me explain you this, what is called choosing of R value between 2 to the 0 to 2 power k minus 1. Okay, let's take a simple example that have a 2 station. You have any other next class?
Yes, sir.
Have any other next class? Anubhav?
Yes, sir.
You have class now?
हाँ सर ಇದೆ ಸರ್ ಈಗ.
You have class now?
Yes, sir.
ತಗೋತಾ ಇದ್ದೀರಾ?
ಹಾಂ ಸರ್, JTM ಮ್ಯಾಮ್ ತಗೊಂತಿದ್ದಾರೆ. ಲಿಂಕ್ ಕಳಿಸ್ತೀರಿ ಈಗ.
ಓಕೆ, ಹೌದಾ, ಸರಿಯಪ್ಪ. ಯು ಕ್ಯಾನ್ ಲೀವ್ ನೌ ಅನುಭವ್.